All right, today we're going to look at general graphs, kind of the parent functions, but in general, when we see these highest exponents, 1, 2, 3, 4, and 5, what did the general shape of the graph look like? So we know linear, so y equals x. Well, because that's positive, we're going to be increasing like we're walking up a hill. If it's negative, we're going to be decreasing like we're walking down a hill. We just got done dealing with quadratics, so like x squared, that would be a U-shaped graph if it's positive. If it's negative, we have this kind of N-shaped graph. X to the third, this might be a little bit newer, and so this kind of has this extra little hump in here, and then it would be flipped if we had the negative of that. So remember, the negative means it takes the parent function and reflects that over the x-axis. X to the fourth, this kind of makes this W-shaped graph, or almost like two parabolas. And again, if that's negative, it would kind of make a little McDonald's sign. They love to see you smile, by the way. And then X to the fifth, this looks like X to the third, but just with an extra curve in there. It's curvy. Now, one thing that I want you to notice is that the end behavior, or the arrows, where the arrows are pointing, every time we have something that has an even exponent, notice how both arrows are pointing up. So 2 or 4, both arrows are pointing up. If we did x to the sixth, both arrows would be pointing up. Now, notice with odd exponents, so x to the first or third or fifth, notice how the arrows are pointing in opposite directions, right? So one's down, one's up, one's down, one's up. And that's true even on the negative side. In the odd parts, one ups, one's down. One is up, one's down. One is up, one is down. So there's kind of this pattern that you'll be able to recognize and notice, hopefully, as we do this more. Let's take a look at end behavior. Let's take a look here in blue with y equals x squared. This is a parabola that shows up or faces up or opens up. And what we're saying is, okay, as x approaches negative infinity, so as this arrow to the left, as that goes to the left forever and ever and ever, what is this arrow doing? Oh, it's pointing up. Well, up would be toward positive infinity. Now, what about as x moves to the right? So as x goes to the right forever and ever and ever, as x approaches positive infinity, so it goes to the right, what is the rightmost arrow doing? And so the rightmost arrow is also pointing up, so also positive infinity. So sometimes you can have both positive infinities, both negative infinities, or one and the other. You can have one positive, one negative. And we see that over here. Let's take a look at y equals negative x to the third. And so if I take this purple marker and use this for y equals negative x to the third, as x approaches negative infinity, so as x goes left and left and left, all the way, negative 10, negative 20, negative a million, negative infinity, as I go left, I'm looking at the leftmost arrow. What is that arrow doing? It's pointing up. So that means y approaches positive infinity. And then as I go to the right, as I look at the rightmost part of the graph, what is my arrow doing? As x is approaching positive infinity all the way to the right, my arrow is pointing down at the rightmost part of the graph. So that would be that the graph is going down toward negative infinity. And again, we'll practice this more in class.